Hi, I'm Stevie C and the place to be. I've still got BigClive's gallium A4 PCBs set up under this piece of timber, so that's why the bench looks slightly different. I'm wary of the bonsai PCBs shorting together, particularly on the LED leads, so I've had another go at bonsaiing the branches, but in doing so I've slashed my hands on the sharp PCBs again. As we saw in the previous project video, it was possible to tame the LED voltage and therefore the current with a 6 amp diode, but that got very hot very quickly as it was dissipating several watts. In this setup, I have the mains coming in through the power meter and into the quick test and then into this MeanWell power supply, which has the voltage trimming pot here. The meter on the left measures the voltage, while the meter on the right measures current. As we can see at the moment, the power supply is spitting out just over 12 volts and it's consuming 5.5 amps. The power supply is rated at 6 amps, so I want to tame the current down. So sure enough, as I start reducing the voltage, we're at 10.2, we're consuming only 3.6 amps now. And you're probably seeing the mains power drop off as well. So we'll go down a bit further, I think. So I'm pretty satisfied with the light output at that. It's running at 9.5 volts and it's drawing just under 3 amps, which means it's now only drawing 30 watts on the mains side. This bonsai quickly grew out of control, meaning it was far too big for the original power supply and the space I wanted to locate it in. So I've assembled another one. I used the same style of base PCB to marshal all the flower stem wires. This one is much more sensibly sized, even if it has already sprouted off into one of BigClive's Snowdrops PCBs. I've been asked to make this bonsai plant for a friend, so I designed another PCB. As you'll see from the sill headers, this is designed to work with these RGB and RGBW LED tape controllers to allow dimming and chase sequences. At the moment, it's running from my bench power supply, but will eventually be powered from a 12 volt off-grid solar system. This has the same circular track design, but has fewer through-holes for bonsai stems to help limit the current draw and prevent project creep. Because I've used RGB LEDs, I needed to install capacitors. Without them, the PWM dimming used by the LED controller causes the RGB LEDs to constantly reset, thus getting stuck on red. Thanks to the RGBW remote, I can have individual control of the groups of bonsai flowers. I can select the red channel, which mostly has red and yellow petals. I can select green, which as you expect is mostly green, but also has white petals. And there's the blue channel, which again is mostly blue, but with some pink. Mostly, however, I can use the dimming feature of the controller to help limit the current. One reason current limiting is useful, as on the solar installation you want to keep the current draw as low as possible to avoid flattening the battery. While it's worthwhile noting that a fully charged battery may be higher than 12 volts, I'm using 12 volts here on the bench power supply. You can probably hear it humming away in the background. So at full brightness, the bonsai plant is drawing just over 1.1 amps. As I start to dim the LEDs, the current rapidly drops off. Here we're down at just over 600 milliamps. At this dim setting, they still give off ample light for a decorative project. You'll probably see some shimmer on the camera. This is due to the pulse width modulation used by the LED dimmer. Down at the very lowest setting, we're only drawing about 64 milliamps. However, some of the LEDs have started to misbehave. This is the bonsai plant installed into my friend's summerhouse and running from a 12-volt solar installation. Here we're using the dimming of the RGB controller to keep the current draw down so as to avoid draining the battery. I've also designed PCB bases and accompanying flower PCBs for a 5-volt version, but I haven't got around to assembling them yet. Look out for them in a future video. Like, subscribe, all that jazz, and until next time, thanks for watching.